So here's the second part of solving simultaneous equations using the elimination method, and this is the special case. Now usually we would take one equation away from the other, and that will eliminate one of the variables. One of the variables will just disappear, leaving either just x or just y, making it easier to solve. This time, instead of taking one equation away from the other, I'm going to need to add them together, and I'll show you why in just a second. Now using my flowchart, first of all, I need to number my equations. So let's start with equation 1, and we've got equation 2 underneath. Now, first question is, does either variable have the same quantity? Well, I've got 3x up here and 1x down here. Remember, it is 1x, but we're lazy mathematicians, so we don't bother writing the 1. Now here I've got 2y and 2y underneath, although of course this time one is positive and one is negative. Now this is the special case where I need to add my two equations together to make these equal 0. And an example of this is if I've got positive 2, like I have there, and I've got negative 2, I need to add them together to make 0. And if you remember from your number work, if I've got two signs next to each other, two signs that are touching, it's too confusing. I don't like that. I need to change it. And if the signs aren't the same, I always say they're not friends. So plus and minus, they're not friends. It's a negative, so it turns into a negative there. So my positive 2, take away my other 2, turns into 0. Okay, so that's why I'm going to add my two equations together on this equation. So I'm going to do equation 1 plus, there we go, it's a better plus, equation 2. So let's put a little line in so it's nice and clear what I'm doing. 3x plus 1x will make 4x. Positive 2y plus negative 2y, put those two things together, it turns into 0, it disappears, just like we explained a second ago. And then that will equal 18 plus negative 2. Well, that's the same as the above thing here. We've got positive 18. I'm going to add negative 2. Okay, well these two things in the center here, it's too confusing. If the signs are touching, I need to change it for a single sign. They're not the same, so they're not friends, so it's a negative. 18, take away the 2, equals 16. So over this side of my equation, I have got 16. So 4x equals 16. I don't want 4 x's, I just want the 1. So instead of having 4 of them, if I divide by 4, I will have just 1x. There we go. And 16 divided by 4 is 4. So x is equal to 4. Now at this point, we're back into our usual kind of flowchart of what we're going to do. I've managed to find the value of one variable, so I'm going to substitute into one of the equations for x is 4. So instead of just having 3x, I'm actually going to have 3 times by the 4. And I'm going to highlight that 4 with a different color just to make it more obvious. So I'm using equation 1 up here, 3x. So instead of 3 times x, it's 3 times 4. And then I'm going to add 2y. I still don't know the value of y, so that stays as y. And it equals 18. Well, 3 times 4 is 12. And then I've still got plus 2y is equal to 18. How can I solve this? Well, I need to keep all my y's on the left-hand side and all the numbers over on the right-hand side. So the first thing to do is take away that 12. This is just back to our solving that we've done before. Take away 12 from both sides. So I've just got 2y on this side because 12, take away 12 is nothing. Over on this side, I've got 18, take away 12, which leaves 6. Well, if 2 times something is 6, that something must be 3. So my answer is x equals 4 and y equals 3. There we go. So remember the special case. If you've got the same quantity of either x or y, so in this case I've got 2 y's and 2 y's, if they've got opposite signs, so one is positive and one is negative, you need to add your two equations together for that one variable to disappear.